All right, we are live. And we will start to get going here as people are making their way in. My name is Adam. I'm with Tessellation and Data Coach. I will be your host with the most. You'll be the judge of that. You can let me know in the chat. On that note, there is a chat. So feel free to chat amongst yourselves or chat to me. Obviously, be respectful, have fun. If you have questions for Elizabeth, there is a Q&A module. That's the best place to ask questions. I'll keep an eye on the chat. You're welcome to ask questions in there, but the Q&A module is a better user experience for me. So that's why I asked you to use that. All right, before we get going, a word from our sponsors, Tessellation and Data Coach. Tessellation is a modern analytics consultancy where we enable and manage organizations' analytics and self-service teams by educating people, optimizing technology, developing world-class products, and providing sustainable results. Also brought to you by Data Coach, where most analytics training programs lack depth. Data Coach provides wisdom. Our modern curriculum is unparalleled, comprising video lessons, hands-on exercises, and a capstone project designed around your company's data. Data Coach also offers a truly premium service, and that is one-on-one coaching. And for the main event, MLOps Explained, brought to you by Elizabeth Dinevski. So let me introduce Elizabeth to you guys. Over the past 5 years, Elizabeth has championed data and analytics in banking, government, technology, and consumer packaged goods. She brings a wealth of knowledge in data science to the analytics community. Elizabeth drives business intelligence strategy, helping teams leverage technology to make data-driven decisions. She specializes in performance management, supply chain optimization, and marketing analysis. From data engineering and modeling to interactive dashboards and visualizations, Elizabeth can transform raw data into actionable analytics. She prides herself on making interactive dashboards and stunning visualizations in Tableau. As a consultant for Tessellation, Elizabeth specializes in providing clients with future-proof data science solutions. And this isn't written on here, but it's something I know personally. Elizabeth is very cool. So I am excited to turn it over to her. Elizabeth, take it away.
Great. What an introduction, Adam. Thank you so much. And thank you everyone for joining our webinar today. Like Adam said, I'm Elizabeth. I am a principal consultant and data scientist here at Tessellation, and very excited to talk about MLOps. What is it? Trying to explain the concept of machine learning operations and scaling models to make it a little bit more digestible. So in terms of our agenda for today, we did the welcome and introductions. We'll talk just briefly about Tessellation's approach to data science to frame up how we're going to discuss data science today, talking about the data science lifecycle, explaining what are exactly MLOps, challenges with pushing models into production, and best practices for productionalizing solutions. So Tessellation's approach to data science. There are five main buckets that I like to use for how we approach data science at Tessellation. First is human-centered. At the end of the day, it is people that are using the outcomes of the models and the analytic solutions. So really focusing on the outputs to solve their problems in a very digestible way that they will use. It doesn't make any sense to put a round peg in a square hole and just hope for the best. So really focusing on the people that are using the solution. Starting small and failing fast is the next one. So focusing on what approaches work and scaling those out versus focusing on ones that aren't doing well. Just ditch the ones that aren't providing any insights and work with the ones that are giving us some viable feedback. Next is iteration, iteration, iteration. So we're big fans of the CRISP-DM methodology and use agile best practices to iterate through the data engineering piece, the business understanding, and a continuous loop until we get the right solution to the problem. Next is built to scale and last. A huge topic of today's webinar is focusing on the model development, not just for today, but building them so they last for tomorrow and the future. And lastly, transparency and enablement, understanding how the code is built, understanding what models are chosen and why, versus a black box approach, which might work, but doesn't give the business any transparency into what is going on. So we're very into transparency and enablement of the tool. So let's start off by talking about the data science lifecycle. So the data science can be an extremely powerful way to solve problems, but with all these buzzwords being tossed around, AI, machine learning, like, is there really an application of those approaches to your problem? So it's really important to understand what is the problem you're trying to solve, and is data science even viable? So I like to ask a few questions before we get started on fixing a problem with data science. First is, what exactly is the core problem? Everybody has different issues that they're facing in their day-to-day business operations, and understanding what the actual root problem is extremely important before you go into building a solution. So do we want to predict if something's going to happen? Do we want to predict what sales are going to be next week? Do we want to categorize something? Do we want to categorize our client base? Or how likely is an event to occur? How likely is someone going to purchase or fulfill this purchase? How likely is a customer to leave? You know, a high profile customer, how likely are they to leave? So what is the core problem that we're trying to solve? Next is, what data is available? We might be able to fully define the problem, but we might not have available data. For example, if we want to look at promotional effectiveness, it's very important to have historical data around promotional drivers, historical pricing, so we can understand those features. If we don't have ideas or data around promotional effectiveness, we won't be able to build a model around it. And lastly, what are the biggest impediments to solving this problem? Basically, why hasn't it been solved already? This is huge because maybe data science is already tested and it just doesn't apply based on the behavior of the problem we're trying to solve, the amount of data, or maybe it's IT infrastructure. Maybe we don't have the right systems in place in order to solve the problem with data science. So these are three main questions I like to ask before we dive into solving a problem with data science. So next on the data science lifecycle is a graphic showing the amount of time it takes for development on the x-axis and the expansiveness of the model in terms of modeling and integration with IT infrastructure. And I know this can sound kind of high level if you're not in the weeds, but basically what it means is how complete is the analytics solution in terms of the results and integrating into IT systems. So is it integrated with our databases? Is it automatic, or is this something that is very manual? So we have proof of concept at the bottom with limited time and limited expansiveness, which is really just the first place to test out and see whether or not data science is an application. Once you've proven that there are some viable results, you scale to a prototype. So proof of concept, you might start with one location or one product, and a prototype, maybe you're expanding to a class of products or a few locations, but still running off of flat files and not fully integrating into the IT infrastructure. Then we go to a minimum viable product. This is maybe looking at all product classes in a geographic region. Maybe it's looking at a few geographic regions, but not the entire portfolio of what we're trying to look at. And then lastly is production. So it's looking at all locations, all products, everything, and it's integrated into sustainable IT infrastructure. So integrating with your cloud architecture, integrating with your databases, being pushed out the results to databases and sustainable IT infrastructure so other analysts can visualize it very easily, and it's integrated into the system rather than just writing out to flat files such as Excel. So if you're still like, Elizabeth, I don't know exactly what you mean, what's the difference between a proof of concept and production? I love to bring in analogies. So today's analogy is about cookies. I mean, who doesn't love cookies? So a proof of concept is trying to find the new best recipe of an oatmeal raisin cookie. So you're at home, you're trying to figure it out in your own kitchen, and you are able to get a really good recipe. So in terms of data science, what that looks like is just trying to see if you can solve the problem with a data science and a machine learning approach. Usually the data comes from Excel files or something of the sort. It's an extract at a point of time rather than updating every week. It's only scoped for a subset of the entire data. So we're only looking at a specific product class, very small, and that helps with the runtime and the development time. So if you're modeling off of a small subset of the data, it's going to take a lot less time to run different models, try different things, and adjust accordingly. Versus if you're running on a larger subset, it'll take some extra time just for model runtime. And the results are going to be pretty promising for that particular subset. They're not going to be perfect, but they're going to show that, hey, this approach is viable. We have the right amount of data and the right data for this problem, and it's promising. So we get that good cookie, but it's just in our kitchen. We can't do much else than enjoy it by ourselves. So when we go to production, we want to have that same quality of that cookie, but be able to just distribute it to different grocery stores. So you're no longer going to be able to produce the cookies out of your residential bakery. You're going to have to go get a commercial bakery. You're not going to be able to sustain that in your kitchen. So in terms of data science, it's taking these models that are already built that have some viability, fine-tuning them, making them better, because not everything's going to act the same in your business, and you might have to adjust on certain types of products, on certain geolocations, you know, really tuning the solution to fit everything as best as it can. The data is going to be fresh. What that means is every week or every time when the data refreshes, you do another rerun of the model with that fresh data versus just a one standard point of time. It's going to be constantly updating. It's going to be connected to your IT infrastructure, connected to your data lakes, your database tables, your cloud infrastructure, making API calls. Depending on what your IT infrastructure looks like, production is going to be integrated with that versus just sitting on someone's personal laptop. It's going to be looking at the entire portfolio, and it's going to be resilient to shifts in the underlying data, which means it's not just going to be overfit for one point of time. It's going to adjust as the data adjusts. So let's take this idea of proof of concept and production and look at it from a use case perspective. So put yourself in the shoes of a soda producer, and we want to create a demand forecast for the products. A proof of concept will be looking at just one specific product category. Let's say orange soda. Proof of concept, we want to forecast orange soda and see how well we do. We're only going to pick that small part of the portfolio. We're only going to use Excel files or CSV files for one point in time, making it very static rather than shifting over time and trying to adjust with that. It's going to be a smaller data pool. It's going to be quicker development time. And during that time, we can test out a variety of approaches. We can try different combinations of variables, different modeling types to see what might make sense for that subset. Once we decide, hey, these are some useful results, how can we scale it out to every single product in every single location? That's when we start putting it into production. The data is going to be so large that we can no longer run it on one person's machine. We're going to have to run it in a cluster or on the cloud somehow so we can get some of that computational power versus, you know, your 16 gigs of RAM on your local machine. It's going to be integrating fresh data, looking at new time periods and adjusting accordingly. And like I mentioned, it's going to be for the entire portfolio, not just for one particular product. And the most important part, it's going to connect inputs and outputs to the live IT system, meaning maybe at the end of the model, there's a database table where different analysts can use for visualization or reporting purposes, rather than one Excel file that might live on a shared drive. So really going into that more sustainable IT infrastructure. So what are MLOps? MLOps, or machine learning operations, is a way of working between data engineers, data scientists, and IT managers to turn a good idea, those proof of concepts, those modeling techniques that we've tried, into a sustainable and scalable analytic solution. This is why I tried to talk about the differences between those proof of concepts that data scientists will be mainly working on versus the whole production. So we're going from just the tip of the iceberg to the entire iceberg. And it allows the team to focus on what they're good at. So it allows the data engineers to understand, they know where a lot of the source data lives, they know the quality of the data, they know how tables link together. So the data engineers can focus on creating that combined data set that the data scientists will need for their modeling. The data scientists can then focus on the actual modeling approaches. They're not worried about cleaning up the data and making it usable. They're mainly focused on trying different approaches, different combinations of variables, different modeling algorithms to see what's the best fit, and determining there might be different best fits for different parts of the portfolio. Maybe new products have to be treated separately than mature products. So they're going to be focused on finding the best modeling approaches rather than other parts of the whole system. And lastly, the IT managers are going to be focused on the overall architecture and determine the best approach from what technology is available, what's the cost, especially when we start talking about cloud computing, what are our computational limits, what are other pipelines that have to run, and how do we schedule this pipeline to run at the right time. So they're focused on the ins and outs of the general IT infrastructure and providing guidance for the engineers and data scientists to write their output to. So going back to our cookie example, so we're deciding we have this oatmeal cookie and we want to scale it out, sell it to Walmart, sell it to Kroger, get it on the shelves. We're not going to be able to do that in our home kitchen. So we're going to open up a bakery, a more commercial bakery. And there are different types of roles that might need to be filled in the bakery. And let's focus on two today. We'll talk about a baker and a mechanic. So when we go from a home kitchen to a commercial kitchen, there are commercial mixers, there are commercial ovens, there are a ton of commercial equipment that need to be not only set up, but constantly maintained to make sure that they are working properly. The mechanic should be focused on making sure all of the equipment is running okay and efficiently, whereas the baker should be focused on the right mix to get the right recipe outputs. They should be focused on how much flour do we need, how many raisins do we need, focusing on the actual recipe, and the mechanic should be focused on maintaining the equipment. They might be able to do the opposite job. That's not the point. The point is they should focus their time on their top skill. This way, the whole project runs smoothly. We're not trying to solve problems that someone already knows the answer to. So really focusing on what you do well at to make the whole well-oiled machine work. So we've talked about proof of concepts, prototypes, MVPs, production. It seems like a very linear process, but there are a lot of challenges when taking those good ideas and putting it into a sustainable production system. And we've been able to boil it down to 4 main areas: data engineering, modeling, architecture, and debugging. We'll start jumping into each one of these. So data engineering, like I mentioned, proof of concept, we're on flat files, we're on extracts. When we push to production, we're connecting to those live data sources. there's going to be changes in the data. There's going to be things that happen in the world that are going to get reflected by sales increasing, decreasing, changing from one product to the other. So as fresh data is incorporated, there's a larger risk of bad data. There's a larger risk of shifts in the data. There's just a larger risk of things happening. And so when we create that ETL process, we want to make sure that it is robust, and so we can anticipate those challenges. And that's a huge challenge when pushing to production, because we don't know exactly what those challenges might be. So we have to work on making that pipeline to be built around anticipating any shifts. Next is modeling. So going from just one product to the entire portfolio takes a lot of computational time and just general evaluation of how the model fits. So there's an additional time, additional resource costs, and just costs in general when we scale to the entire portfolio and make adjustments from there. And modeling techniques might need to be adjusted depending on the behavior of the portfolio. So for example, like newer products might have different algorithms that they do well with to be modeled by versus more mature products. Maybe there's one product that's being phased out and there's a new product being phased in, and we use different algorithms to adjust for those products. So it really just depends on the behavior of the portfolio, but I can almost confidently say that no portfolio, there's one size fits all. It's usually a combination of the different techniques, and that's a challenge when you push to production, is really understanding what are the differences between different product classes, different geolocations, what are variables that we need now to integrate into the model that maybe we didn't need before. Architecture is also a challenge when pushing into production. The data science pipeline needs to be connected to upstream and downstream portions of the architecture. There's going to be input tables, output tables. There might be other pipelines that call those tables run at certain times. So the general architecture of how this fits in with everything else going on in the organization is a huge challenge. These projects get pretty complex pretty quickly, and there needs to be someone who truly understands what's going on with the architecture to be able to guide the team to understand where everything should be placed and why. And then also, if there's any changes to the existing architecture, you're going to need to adjust that and make sure there's no unintended consequences. So if an old table is being phased out, we need to understand what is that connected to? Is that connected to our pipeline? Is there another downstream impact? The architecture can get pretty sticky pretty quickly. And last is debugging. When you scale it out, your model to the entire organization, there's always going to be problems, and it's just finding out what those problems are, identifying where they are, why they're happening, and to be able to adjust accordingly. And also having an appropriate QA environment to start testing any changes in the model before pushing it out to production, just to make sure that everything is running smoothly and doesn't have additional downstream implications. So I've come up with 5 best practices when going to productionalize your solutions. One is compartmentalizing your code. So taking that large pipeline and segmenting it as much as possible so we can decide this is the part of the entire pipeline that's causing the issue, and be able to fix that and bring it back up so it's not damaging the entire pipeline. Next is resilient engineering. I talked about how data shifting, we have to really focus on anticipating data shifts and changes and having quality control checks throughout the pipeline to determine if there needs to be any adjustments. Next is those fine-tuned model enhancements. So deciding where in the portfolio we need to adjust the algorithms, try new algorithms, or even try a new approach. Next is logging. Troubleshooting can be very tricky in data science solutions. Sometimes reading the technical logs are really confusing, and it's very difficult to pinpoint exactly what line of code is causing the problem or what data source is causing the problem. So having logging checkpoints along the way will help understand what point in the pipeline is that problem, how do we fix that problem and bring the pipeline back up. And last is simply expertise. So we talked about in MLOps, it's important for each role to focus on what they're good at. Finding a good team of data engineers, of data scientists and IT managers who have some experience in their respective roles is crucial in making the whole productionalization of your solution a success. So let's talk about compartmentalizing, and I think this is probably the most important part when pushing to production. So what I mean by compartmentalizing is sectioning out your code into smaller chunks to make it easier for changes and debugging. Each compartment will have certain checks that can be integrated into a logging area, whether that be technical logs or business logs, and then leveraging tools such as Docker to segment your code. So if you're familiar with microservices, it is a concept where you have, let's say, a website, and instead of making changes to the entire website, maybe having it go down, you only make changes to one part of the website and make that website live. So even though as a user, you see the entire website, as on the back end, it's just maybe one page that you're editing and making it go live versus editing the entire website. That's the same idea here. Instead of having one giant ETL script to run the entire transformation, you have segmented in different codes and chunks to understand this is where we're adjusting the pricing. This is where we're adjusting the sales data. Different checks in segments like that. So when we need to make a change in one part of the ETL, it's not impacting everything else, or we just focus the changes and can segment the changes on one particular compartment rather than the entire pipeline. And tools like Docker make it super easy to compartmentalize your code and just take that little container, import the Python functions that you need, focus on that chunk of code on getting everything exactly right, and linking everything together as part of your entire pipeline. Compartmentalizing your code also makes it easier for security provisioning to give folks security privileges to certain parts of the pipeline rather than the entire thing, or even certain subsets. So that way, if you have someone who needs to be monitoring the code but not necessarily fixing it, it's a lot easier just to segment who gets what security privileges where. So next, we're going to talk about resilient engineering. Like I mentioned several times before, data is going to shift. Your pipeline in and out is going to shift. Business behavior is going to shift. So we have to work on anticipating some of those shifts. By engineering in smaller parts using that compartmentalized method, it means that only part of your ETL fails. So you can focus on fixing that part of the ETL when there's significant data shift, instead of having the entire pipeline fail and having to determine where was the failure in the first part, why was the failure. So bringing that resilient engineering is extremely important. It's the idea of fixing the room instead of the entire house. So if you have a pipe that bursts in the bathroom, you're focused on fixing the pipe in the bathroom versus looking through the entire house, fixing all the pipes. Anticipating data shift and drift based on certain business metrics is key. So being able to use this resilient engineering to give general business output, such as what was sales in the last 7 days, that could be used to quickly see, hey, is something wrong with something upstream in the pipeline? Did the sales data not transfer this week? Are sales extremely low? That way we know the rest of the pipeline either it doesn't run, or we know that the output's not going to be valid because the inputs were invalid. And lastly, leveraging config files to control certain aspects of the pipeline, especially when there are manual inputs that might need to be changed. So instead of changing those at the top of the script, you can just leverage a config file to configure certain aspects of your pipeline. Next, we're going to talk about Finetune enhancements. So you're going to have to adjust your model based on the entire portfolio behavior depending on how everything reacts when you scale out. So first is identifying where the model is not performing well on a subset. Maybe it's a particular product class, maybe it's a geographic location, whatever it might be. It's really important to segment where the model is underperforming based on your model evaluation metrics. And then next is to adjust accordingly. Some businesses might have the approach of don't worry about the bottom 20% of the portfolio. It's not business drivers. We don't really care about the model results. We more so care of another 1% increase of model accuracy on the top 10% because we get a significant amount of business value from that 1%, that additional 1% rather than the bottom. Focus on the top products, focus getting on those right. Other business approaches might be getting a good enough model on the entire portfolio will be a better business advantage. So that's where you work with some of the business stakeholders to understand where should we be focusing our model enhancements and why. Are we focusing on model enhancements for new products because we have a new push for phasing out part of the older portfolio and replacing them with new products? Is it understanding maybe we have an acquisition coming up and how do we integrate those products with the rest of the portfolio? So that's where the business can guide some of the model enhancements and where the data scientists should focus their time on. And then we iterate on subsets of the portfolio that just don't perform well. So, it could be business or we just, again, the blanket, this is a general subset that's not performing well. And that is where we're going to focus our model enhancements when we scale out. Next is logging. So for those of you on the call that have experience in pushing models to production or any sort of data science or IT development, I'm sure you all are familiar with technical logs and the fun that they are. So part of a successful push to production is also creating business logs. And what I mean by this, in different parts of your pipeline, we have it sectioned out into different compartments. After each compartment, there can be certain sanity checks that make sense to business folks. So maybe it writes to a simple Excel file saying the increase in sales from the last time the model was run, the average weekly sales over the last 52 weeks, different business KPIs that the business would understand. So that way, they know if something looks wrong at any part in the pipeline, they can understand why the model results look off. It's also great to check for model accuracy. So you can have a logging file that's appended every week to look at the training forecast accuracy to see how's the accuracy of the model. Is it increasing over time? Is it decreasing over time? What's going on there? And then also the regular technical logs for debugging. So now that we have segmented our entire pipeline, reading those technical logs can be a little bit easier because we can focus on the exact part of the pipeline where the container went down rather than the entire thing. So really segmenting where the issue is, debugging a smaller set of code rather than a large script. So that way we can focus on, hey, where in this 100 lines of code is the problem rather than where in this 1,000 lines of code is the problem. And lastly, bringing on a solid team of expertise. So bringing in data engineers that have experience with these source systems, the tables that link them together, having experience with big data and Spark environments if you're using large amounts of data, experience with microservices and Docker, understanding the importance and how to implement some of these compartmentalizations that we talked about and the importance of them. And then solutioning across the entire portfolio. We want data scientists that have different skills in modeling and experience to be able to identify where models are performing correctly, where they're not performing correctly, and figure out what parts of the portfolio might react better to different modeling techniques. And it's also extremely important to have collaborative solutioning between business and technical teams. The whole reason why MLOps works is providing open communication. So if there's one thing you take out of today, it's really important to have the core teams focus what they're good at and provide means of open communication. That way, everybody knows what's the status of a project, where things are going, what dependencies there are, what blockers are there, and each team can focus on what they're good at and solving those problems rather than guessing and not knowing what the status is. And that's all we have for today. So I hope that you all learned a little bit about the data science lifecycle, what it means to push to production, what are some of the challenges, and just general best practices.
Yeah, good stuff, Elizabeth. We got a couple questions here. Could you please give an example of what data shift might look like?
Yeah, that's a great question. Data shift, let's use COVID for an example, because it's pretty relevant. Data shift might look like all of a sudden your sales drop 50%. And like in the times of COVID, maybe if we're looking at, I'm a big background in consumer products. So I know at the beginning of COVID, single servings dropped significantly. So think about getting a single serving of a soda is going to drop. People were focused more towards multiple packs or family size servings. So a data shift would be anticipating some sort of shift where the portfolio is completely shifted of how folks are consuming things. So sales drop, sales look very different. And that can mean there's just a general warning of, hey, sales are down 50% from this time of last year. That's an example of a data shift. It might just mean we have to adjust the modeling techniques and approaches. It might mean that we have to start from the beginning. So that's an example of data shift.
Good. Some of the questions you did get to them. How about this one? Someone's asking about proof of concepts, that they seem to build a lot of proof of concepts, but some of them don't go to production. Is there some advice you have on, selling the stakeholders and actually pushing to production?
Yeah, that's a great question. And it is a challenge. There's a lot of great ideas that get tested out. And I think really focusing with the business users on sustainability, right? So that's something I've had to deal with, of really trying to convince users, if someone who owns this process moves to a different role, that entire proof of concept is going to be out of commission. It's not sustainable. It's going to, if someone reformats an Excel file, everything's going to break. So it's so fragile. And for sustainable business, having something, if you're making huge business decisions off of this proof of concept, and a simple reformatting thing in your Excel file can throw everything off, that's a huge risk to the business. So really helping them understand that, someone leaves, someone shifts, someone's computer crashes, whatever it might be, everything's gone. So really focusing on, I know this is a large effort. I know this might be a large cost, but for the sustainability, focus on the sustainability and focus on making things a little bit more, again, stable, making them last for a longer period of time.
Yeah, good advice. How about this one? What are some good projects people in their undergrad can do in order to display their understanding of MLOps?
That's a great question. I would say start getting up to speed on different cloud platforms. So a lot of the MLOps integrates into AWS and Azure. I've worked with a lot of consumer products companies that are on Azure, so it's learning the different components of it and just having a general understanding of how everything works and the different skills that it takes to take a data science solution and put it into sustainable practice is going to put you pretty far ahead if you're an undergrad learning about cloud and MLOps, focusing on some of the roles and some of the technologies, you're going to be in pretty good shape.
Yeah, I'd say so. Okay, we've got to all the questions. Elizabeth, well done. Do you have anything else you'd like to add, or I can wrap us up here?
The only thing I have to add is, if you guys have any other questions, feel free to reach out to us. Here's some contact information for our website, LinkedIn, Twitter, email. that was the only other thing. So
Yes.
Adam,
Awesome.
over to you to wrap up.
Yeah, keep an eye on our websites, tessellationtech.io and Data Coach. Both of them are going to list these live streams, webinars. So please keep an eye on it. We try to do at least one a week. This week we're doing two. So sometimes it's one, sometimes it's two, but keep an eye, sign up, and hopefully we see you again sometime soon. Elizabeth, well done. Thank you, everybody. Have a great day, everybody.
Thanks, everyone.